Hey there, Algebra 3. We're getting ready here to get really close to wrapping up. We have this lesson, and we have one more lesson. Then we study a bit, and then we have your quiz, and then we study for final exam, and that's it. So we don't have a big test on this material. However, you do have a significant quiz, so you do need to make sure that you're doing well on it. And this is really a great section to end on, not this section, but this one and then section 4. A great topic to end on with these quadratic equations because that will springboard you right into your next math. It will be hopefully useful to you if you're taking college placement exams or whatever you're working towards. So here we are. Now you say, silly Mrs. Dowdy, that does not look like quadratic form to me. I don't see an x squared. I don't see anything like that. But what we need to do is we need to work our way into solving that thing. And when we solve the thing, then we have a lot to consider. And our quadratics do have the habit of just showing up just about everywhere. So we need to think about this. First of all, we want to get rid of fractions in the denominator. So to get rid of fractions in the denominator, recall a good strategy is going to be to multiply by the greatest common factor. So in other words, if I was looking for common denominators here, it would have to be x times x minus 1 times 12. So I want to multiply the whole thing by 12 and x minus 1. If it's not obvious to you as far as why we would want to do that, it's because each one of these things is going to cancel out one of the denominators, which is going to make your work easier. So when you distribute this to each piece, this is what this looks like. First of all, 12x times x minus 1, when it's multiplied by this, the x's are going to cancel. When this whole thing is distributed to the 1 over x minus 1, the x minus 1's are going to cancel. And when this whole thing gets distributed to the 7/12ths, the 12's are going to cancel. And what makes that useful is you no longer have fractions to deal with. But what you do have is this. 12 times x minus 1. You have a 12x that didn't disappear, and then you have this. Now, we're getting closer to where you're going to see the quadratics come out, because in order to solve this, you have to actually distribute the 12. You have to start putting things together. So when I have 12, this distributes. When I have 7x, the 7x distributes to both of these. Then you need to move it, so we've got a quadratic equation here. So we've got to move it so that all of everything is on one side of the equation. So you have to subtract the 24x, and you're going to have to add the 12. First we can put like terms together. That's a little easier. So we're going to subtract the 24x, and we're going to add the 12. The reason I wanted to bring it over to the right side is because it's far easier if you have a positive for your leading coefficient. So bring it to whatever side is going to give you a positive for the leading coefficient. Otherwise, you're going to have to factor out a negative and give yourself extra work and extra steps. So now you need to factor this. Okay? Factor if possible, and if that doesn't work, use the quadratic formula. If you want, and this intimidates you, you can go straight to quadratic formula, but I want to take this opportunity to review factoring. This is not a 1 coefficient, so you need to multiply the 7 times 12 and get 84, and find things that multiply to give you 84, and when you add them you get negative 31, so it's going to have to be a negative times negative. Negative 1 and negative 84 doesn't do it. Negative 2 and negative 42 does not do it. Negative 3 and negative 28, wait a minute, that gives me the right answer. But remember, this just gives you what to break the middle down into. It doesn't actually take you straight to the factored form yet. Then you need to factor by grouping. So 7x and 3x just have an x in common. This part, you're factoring out a -4. Remember, if there's a minus in the middle, make sure you're factoring out a negative of whatever your common factor is. And then we have this, because these are our common factors, and x minus 4 is your other part. You can use that then to find x minus 4 equals 0, so one of your answers is 4. 7x minus 3 is 0, so your other answer is 3/7. Oh, sorry. And we have our final answer right here. X equals 4, x equals 3/7. So you've got this process. It takes a lot of writing, but if you follow what makes sense, you can do this. Okay, every single person can do it. Quadratics have a habit of showing up sometimes in the least expected places, like looking at this at the beginning, you may not have anticipated it turning into a quadratic. Quadratics can also show up in word problems. Okay, so we want to take and dissect a couple of word problems, show where the equations can come from, and then how to solve it using quadratics. So for example, you have a boat that can go 12 miles an hour in still water. It takes an hour and 4 minutes to go 6 miles upstream and back. But there's also the fact that the current is pushing the boat. So we need to take our distance equals rate times time to a whole new level, because we have to take into account the speed of the river, it's pushing, either for helping the boat or against the boat. Okay, so we have distance equals rate times time. That's our old friend from way back. And I'm going to say c is the speed of the current, because we need to have a variable for that. So our distance that we go upstream is 6 miles. And the distance that we come downstream is 6 miles. So I'm just going to fill this out chart form so we can keep track of it. Our rate, now in this case it's not just the 12, but when you're going upstream, you have that 12 that you're putting in, but you have to subtract, take away that current, the speed of the current, because that current is going against you. It's making it harder for you to travel. So 12 minus the speed of the current. Going downstream, the current is pushing you, so your rate is 12 plus the speed of the current. Distance equals rate times time. So our time, distance equals rate times time. So our time is found by dividing by the rate. Okay, if we need to see this, 6 equals 12 minus c times time. So you want to find the time, divide both sides by 12 minus c. Same with this, distance equals rate times time. So the time is found by taking 6 divided by 12 plus c. After you have that, we have to consider the total time. These are the individual times, the time it took to go upstream and the time that it takes to come downstream. You can probably figure out that because you've got the current going against you, it takes a lot longer to go upstream than to come downstream. But we have these two values, and together they have to make that hour and 4 minutes. So 1 hour plus 4/60ths of an hour, because there's 60 minutes in an hour. So we're taking our time for upstream plus our time for downstream and making it equal 1 hour and 4/60ths. Well, what do we do with that next? After we have this and we get our common denominator so we can have a fraction, that's when you can do what we did in the last problem. So here's our problem. 1/60th is 60/60ths. So I have 64/60ths, and then I want to make my denominators cancel out. So I'm going to multiply both sides, or all of the three parts, by 60 times 12 minus c, 12 plus c, with the idea that each one of them is going to cancel out a different piece. So for example, for this part, the 12 minus c's canceled out, but I was left with the 6 and the 60 and the 12 plus c. For this piece, the 12 plus c's cancel out, and I'm left with the 6 and the 60 and 12 minus c. On this one, the 60's canceled out. You're left with 64 and both of those things. And even though they're big numbers, just have your calculator next to you and plug in numbers quickly. And you can, once you start doing the problem, it does kind of make it easier. Use information that you know that makes your life easier. For example, this is the sum and difference of two different, it's a difference of two squares actually. So 144 minus c squared. Then distribute. Then even if they're big numbers, don't let that intimidate you. Put your like terms together. 360 minus 360, that's gone. So that's helpful. It's looking nicer all the time. We want to have a positive for our first term in our quadratic. And we say, oh my goodness, what happened here? Well, we don't have, remember our c term, our linear term disappeared. So when you take 84/60 minus 9/12, we get that. But what's up with the 64? Okay, let's cover it for a minute so you don't have to see it. Okay. This is what happens when you add 64c and you subtract 9,216. There's a couple of ways you can go with it from here. Okay. You can simplify it by dividing by 64. Or if you wanted to, you could add 576 to both sides because we have only one variable to deal with. There's a couple ways. So when I divide by 64, I find that 576 is divisible by 64, so that's convenient. Then this is c plus 3, c minus 3. Or you could say c squared equals 9 if you want to just bring this over. So there's two possible answers. C can be 3 or C can be negative 3. But we want to think about what makes sense in our original problem. Okay. If the current were negative, that would mean upstream all of a sudden would mean that you're going faster. If the C, so the C actually has to be positive 3 because when I plug in a positive 3 it makes sense. So sometimes when you do a word problem, you'll get a couple of answers, but only one of them will make sense. So 3 miles per hour is the speed of the current in order to make this work. Okay? All right, we have another one to take a look at. I'll let that sink in for a minute. Okay, this is another rate problem, but it has to do with people doing a job. Okay, you know just from your experience that people work at different rates, and that is the case for anything. Sometimes there's thinking and sometimes there's physical work, but this particular problem is carpeting a room. And so sometimes you have people that will work faster. The faster worker can do the job in 1 hour less time than the other. That means if they were working all by themselves. Together they did it in 4 hours. So you want to find out how much time it would take each one to do the job if they were doing it by themselves. Now there's 2 people working, so you know it's going to be more than 4 hours, but how much for each one of them? So we're going to think this through. First of all, how fast can they do it alone? You have a slower person and you have the faster person. So we're going to just pick a variable to represent how fast the slower person can do this by themselves. Okay, the faster person, okay, so this would be in how many hours. The faster person would take more time or less time. They would take less time. They would take 1 hour less time. So the faster person does it in x minus 1 hour. So this part is key to figuring out this kind of problem. You should write this down. How much of each job per hour? How much of the job gets done, of one carpeting job, gets done in each hour? And that is one job divided by how many hours it takes. And that's how much gets done. So if this person took 5 hours, in 1 hour, it would be 1/5 of the job getting done. If it was 10 hours, it would be 1/10. So 1 divided by however much time it takes to do one job. Now it says in this particular time period, the carpenters together each spent 4 hours. Okay, so by themselves, the slower person takes 1 over however many hours for one job. The faster person takes that much if they're working alone. But this guy's working for 4 hours, and so is this guy. Or this girl's working for 4 hours, and this girl is working for 4 hours. So the number of hours worked is 4. The fraction of the job then that they can complete, the fraction of the job that they will complete in that 4 hours would be 4 times how much they can do each hour. Okay. So the slower person will do 4 divided by x, and the faster person will do 4 divided by x minus 1. They're completing one job. So this is how much of the job this person will do. This is how much of the job this person will do. Together they do one whole job. They do one whole carpeting assignment. So together, if you add the fraction that this one does and the fraction that this one does, you get one job. And once you have this, you can do the strategy that we had before. Our denominator that will multiply everything times x minus 1, so that it cancels out the fractions that are involved. So here we have 4 times x minus 1, and here we have 4 times x, and here we have x times x minus 1. Then we can distribute and work this out. I'm just going to delete it. There we go. Distribute. Make it so you have a 0 on one side. Okay, because if I take away 4x from both sides, and I take away another 4x from both sides, I get negative 9x. I add 4 to both sides, I get 4. Factoring doesn't work for this one. If I try to factor this, I have a problem, because factors of 4 don't give me negative 9 no matter what I do. So we have a problem. We're going to need to use quadratic formula. Or you could complete the square if you want, but it's just kind of annoying. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So we have 9 plus or minus square root 65 over 2. But because it's a word problem, this is not going to be very useful. We want to know how much time. We want to know how much time that this person would spend if they did it all by themselves, and how much time this one would spend if they did it all by themselves. So we need to break it down into its approximates. The square root of 65 is about 8.1. So I need to add 8.1, I need to subtract 8.1. So the slower person will take either about 8.6 hours or about half an hour. You have to look at it and figure out which one makes sense. If it took both of them 4 hours to do this job, there is no way that the slower person is going to do it in half an hour. 8.6 is the number that makes sense. Yes, we did our work correctly, but you've got to look at your answer and say which one makes sense. So for about 8.6 hours, that person could do the job all by themselves. And in about 7.6 hours, the faster person could do it all by themselves because they take an hour less time. Together, it takes them 8 hours. Now notice that this isn't a simple average of their of just adding 8.6 and 7.6 and dividing them and getting 8. Dividing them and getting 4 divide by 2. So you do have to go through a process that's like this and take into account the quadratic formula, but that's how it comes down. Okay? All right, the next ones are not quite this complicated. Okay, so let's move on to something a little bit lighter, a little bit easier. Don't forget that when you've got a square root, in order to undo a square root, you can square both sides. And we square both sides. We want to use the idea of a quadratic equation. We can check for factors. -2 and -4 look great for that. So x is 2 or x equals 4. We do need to be careful with our checking in this case because sometimes you can get extraneous solutions, especially when you're dealing with square roots. So we plug in our values. We plug in 2. We plug in 4. 6 times 2, 12. Minus 8 gives you 4. Square root of 4 is 2. 6 times 4, 24. Minus 8 gives you 16 equals 4. Hey, we didn't get an extraneous solution. It worked out great. Both of the answers are solutions. So we have that. Okay. And another one. This one looks funny because it looks like it's not a quadratic, but it's a hiding quadratic because this is really x squared squared. So you can think about this as being just one particular thing squared. Okay, so since it's x squared squared, you can factor it like normal. We're looking for factors of 36 that are going to give you -13. And factors of 36 that'll give you -13. When we go down the list, we find out that -4 and -9 work. But instead of having just an x here, we have an x squared here. Now, interestingly enough, these two both come out to be different of two squares. So this one will be x plus 2, x minus 2, and this one will be x plus 3, x minus 3. Or we can go ahead and set it both equal to 0 first and then do what I just said. So we have x equals -2 or x equals 2, x equals 3 or x equals -3. You have 4 answers to this problem. Now, interestingly enough, algebra tells us that if we have an exponent of 4, we're expecting 4 answers. Those answers can be real or they can be imaginary or various different things. So sometimes they don't all come out, but really 4 answers is what you're ultimately looking for if you have an exponent of 4. And that goes for others as well. So for example, this one ultimately will have 6 answers. We may not find 6 answers because sometimes they can be duplicated, but there's a potential for 6 different unique answers here. So we're going to do the same scenario, we're going to make it equal to 0 and look for hidden squares, look for hidden quadratics. So this is really 4x cubed squared. So we have a 4 coefficient of x cubed squared, and then you have an x cubed in the middle. Whatever is squared at the beginning has to be by itself in the middle in order to use this technique. 4 times 1, I'm looking for factors of 4 that give us -5, which is right here. So I have this. I'm looking for common factors now. I'm looking for that x cubed to come out. And then I'm looking for a -1 to come out. Now the interesting thing here is that on this one anyway, you have a difference of cubes. But we don't even need to go there because you can divide it out like this first. Okay. X cubed equals 1. So in order to solve that, you take the cube root of x. Cube root of x is just 1. So here's a 1. The cube root of 1/4 is square root of 3 over 2 once we finally, cube root of 2 over 3. Wow. Cube root of 2 over 2. I'm going to untie my tongue one of these days here, because when I cube root both sides, cube root numerator and denominator, I need an extra 2 to make it a perfect grouping of 3 2's, because the cube root of 8 is a perfect cube, which will give me 2. I need an extra cube root 2 here to give me cube root 2 over 2. Here's my second answer. The other answers are hiding in some other form or they're duplicate answers, but we've managed to find the answers, find all of the answers that are there. So x equals 1 or x equals the cube root of 2 over 2. Okay, that is it. I leave you to doing your assignment. Please work on it carefully. Assignment 75 is due tomorrow. And I worked it out so that the weekend is not bogged down with work, but tonight's your hard day. So work it out today, and you've got this. Have a wonderful, great, blessed day.